Here we go. So we're going to use the whole period today. So, ladies and gentlemen, please remember that I grade your notes, and your notes should have the date, and they should have the title. I like you to write down an objective, but that's your call. So please make sure everything's dated and titled. All right. In that blue box, you'll find a selection of materials that we're going to use today, which is going to be super fun. And the first of which is this. What is this? Protractor. Protractor. Raise your hand if you have never used a protractor. Not properly? Yeah, that's what I want to make sure we know how to do. I'm not so anal retentive that I'm going to make you draw a perfect 60-degree angle. But I do want to make sure we all know how to use a protractor, because you will have to use the protractor when we do the unit circle projects, I don't know, like next week or so. Yeah, so to get started, to draw, I need a straight segment. Now, in order to draw an angle is formed from two rays. And if you remember your geometry terminology, a ray has an initial point, and it goes on forever in one direction. Okay. So this would be what we would call the initial side of our angle. All right, and it is important that we have an initial side. And then, in order to use the protractor, all of the protractors have sort of what I would call the origin, where you can see here on this one, there's a vertical and a horizontal, like a y-axis and an x-axis. This one happens to have a hole in the center. Yours might not. All protractors are just a tiny bit different. You should also look and note that where 0 is. So here is 0, and then we count 10, 20, 30, 40, 50, 60. We could go the other way as well, looking at the outside numbers if you wanted to. And so what we want to do then with our nice straight segment is put our initial point here right at the origin, what I'm going to call the origin. And then you have to line your segment up so that it falls at 0. So it's starting at 0 degrees. And then you would count 10, 20, 30, 40, 50, 60 and make a mark. And then use that mark to draw the terminal side of your angle. All right, so this is the terminal. That is the terminal side of your angle. Now, in order to label that angle properly, ACE would be one way that you could label it. It's been a decade since I taught geometry. I think the middle letter is the vertex of an angle. So C goes in the middle. C goes at the vertex. Okay? So this is the vertex of the angle. And the way that I drew this is what we would call an angle in standard position. Okay? Which I'll talk more about in just a second. But it is important that we have an initial side of an angle and a terminal side of an angle. All right, so first up, we have vocabulary. And I will be working in a lot of examples as we go through this vocabulary, so make sure you get them all down. Okay. Vocabulary. Angle is first up on our vocabulary list. An angle is an amount of rotation. An angle is an amount of rotation. And in this class, in trigonometry, all of our angles are going to be drawn in standard position. The standard position of an angle is that the initial side the initial side follows the positive x-axis. The initial side follows the positive x-axis. And this is really important, which means that there's going to be an x-axis. All of our angles will be sort of superimposed over a typical xy coordinate plane, okay? And so, let's say I want to draw a positive angle. A positive angle opens in a counterclockwise direction. Counterclockwise direction. All right, so let me give you an example here. So first, we want to draw an angle in standard position. Standard position means that I have to have an x and a y-axis. So we're going to make a sketch. Little sketch here. There's my standard coordinate plane, xy axis. And I want to draw an angle in standard position. Standard position means the initial side follows the positive x-axis. And we put our initial point at the origin. And so then I have my initial side running along the positive x-axis. So here is my initial side of my angle. Now let's say I want to draw the angle in standard position, and I'm going to give me a number between 10 and 200.
200. 25. 69.
So I'm going to go, I heard 54. I'm just going to go 55 because. All right. So we're going to draw the angle 55 degrees. You'll notice that I have the degree symbol. That's really, really important. Make sure you always write a degree symbol if there's one there. 55 degrees is a positive number, and so this means that my angle is opening upwards, and it's opening up, well, 55 degrees. I'm not going to use my protractor. I'm not quite that anal retentive. But we know that 55 degrees is less than 90. Where's 90 degrees? Straight on the y-axis there, right? Okay. So what we need to, this is what we call the terminal side of our angle, which you should already know. And you'll notice I wrote this little arc mark here with the arrow. That is indicating direction. Indicating the direction that we're opening this angle up in the positive direction, since it's going counterclockwise. And we would put that 55 degrees in there as proper labeling, okay? I am a stickler about labeling, so please label properly. Now, it's important that we understand that because we can also have negative angles. What do you think a negative angle is? Opens in a clockwise direction. And again, all of our angles are going to be from standard position. So it has an initial side, again, running along the positive x-axis. But now it's going in the opposite direction. It's going clockwise, opening downwards. So I'm going to call, let's see, 125. Negative 125 degrees would be a negative angle, which really just means it's 125 degrees in the clockwise direction. Now, 125 is more than 90. So here might be negative 125 degrees, just about. Yeah. Always along the positive x-axis. Yes, the initial side is always along the positive x-axis. Good. Complementary. What is complementary? Okay, so 90 is what I was looking for. Complementary angles are two angles that add to 90 degrees. Two angles that add to 90 degrees. This little, that's shorthand for angle. Have you seen that before?
Yeah.
Yeah, okay, good. Sure. Some teachers do it this way, but I don't like that because in physics, we draw an eyeball that way. So I don't, yeah, an angle. There we go. So that's also an eyeball. You see it now? Okay. Sorry, I digress. You didn't need to know that. So let me ask you, looking with our angle of 55 degrees here, what would its complement be? How do you get 35? Yeah, so we could think about completing that to get the right angle there, and that would be 35 degrees because 35 plus 55 would give us 90. So we could say that the complementary angle is 35 degrees. You can also subtract from 90. 90 minus 55 gives me the 35. Okay, a lot of what we do today is just in your head. All right. All right. What is supplementary then? Two angles that add to 180 degrees. Very good. So what is the supplement to the 55 degree angle? What is the supplement to the 55 degree angle?
Yeah, 35.
125 is right. Right here. To add to be 180 degrees. 180 degrees is the straight angle. And so right here, 90 and that 35 gives you 125. So the supplementary angle is 125 degrees. It is possible that you might not have a complement, or you might not have a supplement because they would be too big, okay? Or negative, which doesn't make sense. So, so look out for that. All right, the next thing I want to talk about are coterminal angles. Coterminal angles. Coterminal angles have the same terminal side. They have a coordinating terminal side. They co-terminate. They stop at the same place. Okay? So again, looking at this 55 degree angle, I want to figure out another angle that again starts on our initial side here, that positive x-axis, and it opens up and it terminates at this same place. Negative 305. How'd you get negative 305? Okay, so very good. So if you went this direction, opening downward to get all the way around, 360 minus that 55, let's see, 360 minus the 55 degrees gives you, what'd you say, 305? All right, so that would be a negative 305 degree angle. That is what we would call the negative coterminal angle. Good. So negative 305 degrees is an example of a coterminal angle. What about a positive one, though? $35? Our angle has to begin at the same place as well. It always has to start from the positive. Can you do it the other way? So does 55 work? Well, that's the angle that we started with. So no, that is no good. You can't give me the same answer. So give me another one. 415. I heard 415. Yeah. So 55 we've already done, but could we keep going around?
Yeah, right.
Yeah, we absolutely can. We can go around. We can rotate as much as we want. So if I go around a complete rotation, how many degrees have I gone? 360. And then I need to continue on a little bit more. How much more? 55 more. And that's going to give me 415 degrees. And that would be a positive coterminal angle. You'll notice this little swirly I drew. That would be the notation for indicating that we've rotated more than a full rotation and beyond. So one whole rotation and a little bit more. It's like a little spiral if you need to do that. To indicate that you're going more than one rotation. Okay. And that is really important. We want to be able to draw these so that other people understand them. Okay. Now, a central angle is, I'm just going to draw a picture. A central angle is an angle within a circle. So I'm going to start just by drawing a circle. A circle always has the very center of the circle. And a central angle is an angle where its vertex is at the center of the circle. So here, this might be ACE again. Angle ACE is a central angle. So it's an angle that its vertex is at the center of the circle. Now we get to draw a lot of these central angles. They're really important to us. So you guys are really good at degrees. You've been working with degrees for a very, very long time. And so you know that we can open up an angle, we can go 90 degrees, and we can go 180 degrees and more. How many degrees gets us all the way around? 360 degrees is one full rotation. But the problem with degrees is my question to you, why 360 degrees? 180 plus 180. But that's actually just the result of declaring it was 360, right? Does it have to be 360 degrees? It could be 2 degrees, right, Lee? 1, 2. Okay? So it could have been 1,000 degrees, right? We could go 500 degrees gets me halfway and 500 gets me the other half. 1,000 degrees to get a full rotation. Why did they choose 360? They like the number. There is no reason. It's completely arbitrary. They, the people 1,500 years ago who thought this up. All right? So that arbitrary number has no meaning. And it's not very helpful either, because I need you to imagine for a minute, you're sailing, because, right, we did degrees stuff in navigation, okay, long time ago. And let's say you're supposed to be heading due north. Okay, so you're in a boat, you're heading due north, but let's say you got off a degree. You got off 1 degree in your navigation, but you had just gone 500 miles in your boat. How far off your mark are you? Pretty damn far, right? Right? You're a degree off, but over time, over distance, that is a long way off. All right? So a degree isn't great, because at far distances, you can be really far off your mark. And so as a result, they had to subdivide degrees. So degrees are actually, then 1 degree is broken up into 60 minutes, which is just 60 little portions. And then each little minute is further segregated into little seconds, degrees, minutes, and seconds, which is how your GPS gives you latitude and longitude figures. You'll see degrees, minutes, and seconds. Now, I don't talk about that stuff in this class because it's very archaic. But we do want to talk about why degrees aren't great. And it's because they're arbitrary, where somebody just said, hey, let's make it 360, and everybody just sort of jumped on board. Okay, but what we have now is radians. And so we're going to talk for a long time today about radians. What are radians? Radians. Go ahead and write this down. This is the definition of radian. One radian is the measure of the central angle theta. This little figure is theta. It is the Greek letter that we use to represent angles in trigonometry. So you'll see theta all the time. Theta. One radian is the measure of the central angle theta. And again, a radian is still a measure of rotation, just like angles are. That intercepts an arc, S, equal in length to the radius R of the circle. So the radius of the circle is equal to the intercepted arc. So I'm going to talk about that central angle and the intercepted arc in just a second. Intercepts an arc S equal in length to the radius R. So the arc S is equal to the radius R. All right, so I like when I can do like little hands-on things because I really wanted to be an elementary school teacher when I was growing up. So it's not too late. Should we just call it quits?
Yeah.
Okay. In your blue bin, you have a jam jar lid. There's 2 of them, so you are going to have to share. But what I'd like you to do is trace this jam jar lid on your paper. Because tracing a circle is easier than using a compass. All right. And, you know, you're going to have a lot more notes, so you might as well move on to the next page if you need to. All right. So, first of all, it says that we're going to have a central angle, and all of our angles in trigonometry are going to be in standard position, so I also need an x-axis. I need this circle to be centered on an x-axis. So I want to draw the diameter of this circle. So I'm going to use a straight edge and just find what I believe to be the widest, the diameter, the largest portion of this circle. Yes, it does. But all of our school compasses are crap, so. And in fact, we don't have any protractors. All of these are my protractors.
Not this one.
Not that one? Oh, you have your own. Awesome. Okay. Then we also, this needs to be a central angle. So our angle that we're drawing has to go through the center of the circle. So I do need to find the center. My radius is about 8.5 on mine. And so that's like 4 1/4. So I'm marking my center about right here. All right. So I have what I lovingly am going to call, this is my like x-axis. And you can imagine there's like a y-axis passing through here, but I'm not going to draw in the y. I just need that positive x-axis. And what I'm trying to do is I'm trying to draw a central angle. So there's going to be we have our initial side right here of our angle. Here's our initial side along the positive x-axis. And I'm going to be opening up a central angle where the length of the intercepted arc. The intercepted arc is, if I have my angle here, the arc on the rim of the circle is what we call the intercepted arc. And I need that intercepted arc to be equal to the radius of my circle. Well, how am I going to find the radius of my circle? Half the diameter. So you have a little pipe cleaner in there. it's important you do this. There might be some little pipe cleaner pieces already in there, but so I'm going to take my pipe cleaner and find where it looks like it's the longest, and then use the scissors to cut it. So I can get the diameter. What am I going to do once I have the diameter? Cut it in half, and that'll give us the radius. Not only will it give you the radius, but it'll give you 2 radii, which you can share with your neighbor. See, look at that. We're sharing is caring. All right, so you're going to fold it in half. Fold it in half, and then cut it. Cut it in half, and then we get 2 little radii. Cool, right? Okay. So then, a radian is an angle measure, amount of rotation that is equal to this length of the radius, where I'm going to take this radius length and wrap it around my circle I drew and make a mark right there. This is my length R, and this is my intercepted arc that is the same length.
There you go, you're gonna need it.
So, I can now connect and draw in my central angle. This is my central angle theta that happens to be equal to 1 radian. We just drew 1 radian. 1 radian really means the length of a radius around this circle.
What angle is that?
That angle theta is the measure of 1 radian.
60.
Yep. How what? So I took my radius length and I wrapped it on the rim of the circle. Okay. So now, how do you make 2 radians? Theta equals 1 radian. All right, so how do you make 2 radians? Use your pipe cleaner again. And you lay that on your circle again. And make a mark. And now I've drawn the angle that is 2 radians. So this angle right here is 2 radians. All right, ladies and gentlemen, continue around the circle. I want to know how many lengths S or how many S's get all the way around the circle.
6.
Go and try it. Don't guess. I want you to actually mark it. Move your pipe cleaner and mark it. Move your pipe cleaner and mark it. No, I know mine's I think it was meant to do yeah. So like if you did your next what is this?